Hey there, fellow Earthlings. We all know water. We drink it, swim in it, and sometimes even spill it. But have you ever wondered, what does water do in space? You know, that place where gravity doesn't tell things which way to fall? Here on Earth, gravity is the boss. It pulls everything down, including water. That's why rivers flow downhill and raindrops fall from the sky. But in space, things are different. Way different. Imagine floating around in a spaceship. No up, no down, just you and a whole lot of floating stuff. Hopefully, you remembered the duct tape. Water acts pretty wild in this environment. It doesn't know which way to go, so it does something really cool. Want to know what it is? Keep reading to find out. Remember those cool water balloons we talked about? Here's the thing about water, it likes to stick to itself. Scientists call this cohesion. It's like water molecules are holding hands with their little water molecule buddies. Now imagine you have a bunch of tiny water magnets all clumped together. That's kind of what happens in space. Without gravity pulling them down, the water molecules huddle up in a shape that lets them hold the most hands, a sphere. These floating water balls are pretty amazing. They can be as small as a raindrop or as big as a basketball. And because there's no air and space to slow them down, they can float around for a really long time. Just try bouncing a water balloon in space. Hold on to your space helmets because things are about to get even weirder. What happens when we unleash water into the vacuum of space? It's not just about floating blobs. Oh no, it's way more dramatic than that. First off, the water boils. Without air pressure to keep it in check, the water molecules go bonkers and turn into vapor, like a pot of water boiling over on your stove, but way faster. But wait, there's more. While some of the water is busy becoming a gas, the rest of it freezes. That's right, the same water at the same time can be both boiling and freezing. It's like a tiny space ice volcano. How is that possible? Well, the vacuum of space sucks away heat super fast. So while the surface of the water is busy boiling away, the inside chills out and turns into ice. It's a wild cosmic dance of states of matter. Section 4. Astronauts getting thirsty, water's importance on the ISS. Imagine you're an astronaut living on the International Space Station. You're orbiting Earth doing science and enjoying the best view in the solar system, but there's one small problem: you're thirsty. Just like us Earth dwellers, astronauts need water to survive. They drink it, use it to rehydrate food, and even need it for some of their experiments. But shipping water up to the ISS is expensive and takes up valuable cargo space. That's why NASA came up with some pretty ingenious ways to recycle water in space. Think about all the water astronauts use every day. Shower water, sweat, even the moisture from their breath. It can all be recycled. Section 5. Filtering out the space bits. NASA's water recycling magic. So, how do we turn, used water back into something drinkable? That's where NASA's incredible water recycling system comes in. It's like a giant Brita filter for the space station. First, the system collects all the wastewater. Then, it goes through a series of filters that remove impurities like hair, food particles, and even bacteria. After that, the water is heated up to kill any remaining germs. But the recycling doesn't stop there. The system can even extract water from the air like a dehumidifier on overdrive. This means even the astronaut's breath gets turned back into drinking water. It's a closed-loop system, which means almost no water is wasted. Section 6. Water everywhere. The search for H2O in our solar system. We've talked about water on Earth and water in space stations. But what about water out there in the vast cosmic ocean? Turns out water isn't as rare as we once thought. Scientists have found evidence of ice on the moon hidden in craters that never see sunlight. Mars, our rusty red neighbor, has polar ice caps and might even have liquid water flowing underground. But the real water jackpot might be out in the outer solar system. Jupiter's moon, Europa, and Saturn's moon Enceladus both have giant oceans of liquid water trapped beneath their icy surfaces. These oceans are thought to be even bigger than all the oceans on Earth combined. Why are we so obsessed with finding water? Well, water is essential for life as we know it. Finding liquid water on other planets and moons means there's a chance, however small, that we might not be alone in the universe. Section 7. The future of space water. What's next? As we continue to explore the solar system and beyond, understanding water in space will be more important than ever. Water will be crucial for future space travelers, whether they're headed to the moon, Mars, or even further. Imagine astronauts farming on Mars, using hydroponics to grow food with recycled water. Or picture underwater robots exploring the hidden oceans of Europa, searching for signs of life. The future of space exploration is full of exciting possibilities, and water will be at the heart of it all. So the next time you take a sip of water, remember that something so simple here on Earth is a precious resource in the vastness of space. And who knows what amazing discoveries await us as we continue to unlock the secrets of this incredible molecule.